Solving systems of equations with two variables can be easy, but when you get to 3, 4, or even 5 of them, that's when it starts becoming a little bit messy. Today I'm going to be showing you Gaussian elimination, which is basically the way you solve linear systems once it gets to a higher degree, and you eventually will turn this into a matrix. So we'll start off with our equations, which would be x plus y plus z is equal to 6, 2x minus y plus z is equal to 3, and then x plus 2y plus 2z is equal to 11. So our goal is to turn this into an augmented matrix, which is basically meaning that we strip away the x, y, and z, and we just look at their coefficients. So we'll start off with that. So we look at the first equation and we notice it's 1x plus 1y plus 1z is equal to 6. Then we go to the next one, 2, and then negative y, so minus 1, 1, 3. And then 1, 2, 2, 11. And I like to put a line right there to show the equal sign. So that's our augmented matrix. Eventually, we would like it to turn into this, which is basically what we call row echelon form. You would want ones on the diagonal, zeros under all of the ones, just like that. And then you can put whatever ends up being there, you put there. And basically, this helps us to solve it because eventually, imagine looking at this as a equation. It'll be 0x plus 0y plus z is equal to something, and that basically gives you the answer for z. And then you plug it into the second equation, and that'll help you solve for y. And then lastly, you plug it into the first equation and you solve for x. So that's basically the logic behind getting it into row echelon form. So to do that, we want to first start with this. And there's 3 rules when you're trying to solve a matrix. One is you can swap any 2 rows with each other. The second one is you can multiply a row by any non-zero number. And then the third row is you can add or subtract a multiple of one row from another. This is what we're majorly going to be using. So let's start with solving it. We want these 2 to turn into zeros, right? To go into row echelon form. That's our first task. To do that, we will do R2. I'll call this R2, this R1, and this R3. Row 1, row 2, row 3. So we want to do row 2 minus 2 row 1, and that'll become the new row 2. So we aren't going to be manipulating the first one, so we can just write that out. So then we do 2 minus 2 times row 1, so that'll be 1. So 2 minus 2 will equal 0. So 2 minus 2 times this, and that'll become 0. And you basically go through the whole row and do the same thing. So negative 1 minus 2 would be negative 3. 1 minus 2 would be negative 1. And then 3 minus 12 would be negative 9. And it's always good to go back and check your work. So 2 minus 2, yup. Negative 1 minus 2, yup. 1 minus 2, yup. And then 3 minus 12, yeah. And we have to do the same thing for R3. We have to make this 0, but we see that the first number of R3 and the first number of R1 are the same. So we don't really need to multiply by anything. We just need to subtract. That's it. And that'll become the new R3. So 1 minus 1, 0. 2 minus 1, 1. 2 minus 1, 1. 11 minus 6 would be 5. So we did our first step. We have 2 zeros right there. We just need one more 0 here. And to do that, we will look down at R2 now. We know that row 1 isn't going to get manipulated, so we can write that out. And for right now, row 2 isn't, so we can write that out. So now row 3. We want row 3 and then some form of row 2 to make this a 0. So negative 3 times what? Times y, we'll just call it y for right now, is equal to 1. So it would be negative 3 y is equal to 1, y is equal to negative 1/3. So what we see here is you want to do row 3 plus 1/3 row 2, and that'll become the new row 3. So 0 plus 1/3 times 0, that'll still say 0. 1 plus 1/3 times negative 3, that'll become 1 minus 1, which will equal 0. Boom, exactly what we want. Then 1 minus 1/3, which will equal 2/3. And then 5, we can do negative 9 times 1/3, which will be negative 3. So it would be 5 minus 3, which would equal 2. And we have it exactly where we want to be. Now all we have to do now is make the diagonals 1. So to do that, it would be 2/3 z is equal to 1. So we want z to equal 3/2. So R3, 3/2 R3 will turn into the new R3. And we want this to be 1. So we'll do that later. 1, 1, 1, 6, we have exactly what we want in row 1. And then 0, 0, 2/3 times 3/2 would be 1. And then 2 times 3/2 would equal 3. So it would be 3. And we want this to become 1 now. So it would be negative 3y is equal to 1. Y will equal negative 1/3. So we have to divide the whole second row by negative 3 now. So 0, negative 3 divided by negative 3, 1. Negative 1 divided by negative 3, 1/3. And then negative 9 divided by negative 3, 3. Just like that. So now we look at the last line. So it'd be 0x plus 0y plus 0z, or 1z is equal to 3. So we know z would be equal to 3. And then we plug that into the second line, which would be y plus 1/3 z is equal to 3. And we know z is 3, so we do y plus 1/3 times 3 is equal to 3. Y plus 1 is equal to 3. We know y will be 2. So we have the first two, and now we plug it into the first equation. So x plus y plus z is equal to 6. And we know y is 2 and z is 3. So it would just be like that. And then you solve for x. X plus 5 is equal to 6. X is equal to 1. So we have our final answer. X is equal to 1. Y is equal to 2. And then z is equal to 3. Just like that. So going all the way from this to this didn't really require that much well, it required some computation, but it wasn't very difficult. And that's basically how Gaussian elimination is supposed to help you. It's supposed to take you to what seemingly feels impossible into an easy answer where it's just substitution. I hope that this helped you and you will use it in the future. You can do harder equations and keep practicing. All it takes is practice. Thank you.